So as you all are aware that since some of the previous lectures we have started our new series of advanced data structures and algorithms. The topic which we are presently learning is about tries, and in the previous lectures we have seen what actually a trie is, and what kind of data structure it is and why it is used, and we have taken a fair introduction about fair and detailed introduction about the tries. Going further with that particular agenda only, today's topic is also about tries. So here in this lecture we will be covering about some applications of tries where actually these tries are used. So let us begin with a quick recap of tries, and then we will move with our today's agenda. So trie, as I told you in the last lecture, is basically a data structure which you can categorize as an advanced kind of a data structure, basically a tree based data structure in which the nodes are structured in a particular way, and because of this structuring of nodes, the words or the strings can be retrieved from this trie by traversing down a branch path of the tree, and each trie is having an empty root node with link or references, I can say, to the other nodes, one for each possible alphabetic value. Now why I am talking about alphabetical values here, because these tries are mostly used for strings, but there can be other values also, or there can be other scenarios also. The shape and the structure of trie is always a set of linked nodes connecting back to an empty root node. Now the number of child nodes in a trie depends completely upon the total number of values possible. Now the total number of values, for example, if we are representing the English alphabet, then the total number of child nodes will be directly connected to the total number of letters possible, which is 26. Or if we are looking for the representation of a binary number, then obviously the total number of child for any particular node can be maximum 2 for 0 and for 1. So here is an example which we discussed in the last lecture, which is a standard trie for the set of string S, and that string S is having 8 strings: beer, bell, bid, bull, buy, sell, stock, and stop. And how this tree is formed, that we have seen. So empty root node is there, and then possibly links, and this is also a kind of a search tree. All the nodes are arranged in a particular kind of order, we can say. So here is kind of that an standard tree. Now moving further, now when we want to look for a particular key, or when we want to store a particular key which is a prefix of another. So for example, we have different words. We have, let's say, we have word and, we have word any, and we have word at also. So how are we going to store these words, or when a particular key is a prefix of another key, in that situation how this storage is going to help, or how can we know that n is a word, and that this n is a complete I can say prefix of the word end. So in order to kind of model these kinds of situations, you can have look you can have a look at the figure in which we have a root, then we have a left branch which is starting with A, then N, and then D, and with N there is there is another branch which is going on out, which is Y, making it any. So if someone wants to kind of make themselves available that n is actually a word, that means we need to actually put on a termination character, maybe kind of any sentinel character. We can take a dollar over here, which is going to mark, or which is going to demark the end of a particular word. So in this situation we are going to add a special termination symbol which we are taking as dollar, and this dollar will be appended to each keywords. Now let us say I am going to take the string S, the set of strings S as n and any and at. Now here you can see that starting from the root, the A is the kind of common character. On the left side, this tree, because of being an kind of an ordered tree or being on search tree, N is on the left side, T is on the right side. So at, and this at is terminated with the help of a dollar. N, then N is also terminated with the help of a dollar. Then N, if carried forward in the form of and in the form of any, which is going to give us a branch to D, the character D, and to the character Y, that A and D is again terminated with dollar, and A and Y is terminated with dollar also. So here we have added a special termination symbol. So you can compare the previous tree which I have just shown you, which is shown on the screen, in which there is no termination symbol and there was no way of knowing that when a particular string is a prefix of another string, or when a particular key is a prefix of another key. So in order to model those kinds of situations, we will be taking, or we will be kind of converting this tree into something of this sort, in which a special termination symbol is being appended to each and every string or keyword, and this special termination symbol is actually we can say marking the end of a particular keyword or a string. So this is one kind of scenario which is possible, because when we talk about the applications of when we talk about the application of tries, I have already told you that in this try is actually suitable, this try is a suitable data structure for modeling dictionary scenarios. And now in dictionary, this is perfectly possible that one word is a complete prefix of the another word. Now in this kind of situation, when we are making our dollar symbol as the termination symbol, our searching also becomes kind of, we can say, very easy, in the sense when there is when there is the requirement of a search operation, or when there is a search is to be performed, we are aware that the search is going to end with a dollar symbol. So for example, in the given scenario or in the given try, if we are looking for the word C, so in the right side of the root node, which is actually an empty node, we have S, then we have E, and there are basically two words, one is C, another one is set. So SEA followed by a dollar symbol. So it is easier to look for a particular keyword or look for a string, and till you are going to hit the particular, till you are going to hit the dollar symbol, which is kind of an indication of the end of the string. So search is also becoming kind of, we can say, channelized or more organized by this way, if we are appending dollar by dollar at the end of every keyword. Now coming to the application of tries, as I told you that one thing which is kind of in dictionary scenarios, this try is going to be a very kind of prominent structure, or a very useful structure, I can say. Another application of tries, or more standard application of tries, are basically divided into two categories. One is the word matching, another one is the prefix matching. So a standard try supports the operations of word matching as well as the prefix matching in order m time, where m is nothing but we can say the number of characters in the X. So for example, if we are going for the word matching, then the problem is actually to find the first occurrence of word X in that particular text. So X is a string, and this pre-processing or this operation can be done in order m time. So the first occurrence of word X in the text is to be looked for, which is word matching. Coming to prefix matching is actually finding the first occurrence of longest prefix of word X in the text. Here both of these operations, whether it is a prefix matching operation or it is a word matching operation, both of these operations are performed by tracing a path in the trie starting at the root. So, we need to start at the root and then we need to perform kind of matching of matching word to word, letter to letter matching, and this letter to letter matching will be traced down along with a path from root to the leaf going downwards in the tree. So, here you can have an example of word matching with a trie. So, here the words of the text are inserted into a trie, and what is the text? Text is see a bear, sell the stock, and see a bull, buy the stock, and so on and so forth. So, basically an array of characters which is in the form of a text or a piece of text we can say is given, and every character is being numbered here as I am talking about an array. So, it starts from 0 and it is coming down to 88, and so total 89 characters are there, and each leaf stores the occurrence of the associated word in the text. So, here if you can see the kind of example which is given on the screen, if you can trace the first path down, so that starts from B and then it goes down, and at the last the leaf, at the leaf node you can also see a number. So, these leaf entries are actually storing the occurrences of the associated word in the text, in which in this manner a word matching with a trie is possible, or it is being done. Now, coming to the next application, which is about longest common prefix. So, longest common prefix is actually can be accomplished with the help of trie, in which all the words are inserted one by one in the trie, and after inserting we need to perform a walk on the trie, and in this walk we will go deeper until we find a node having more than one children, or more simply we can say we will go deeper until we find a branching occurs or 0 children. That means either one of the string gets exhausted, or we are having any branching. So, either a branching occurs or the exhaustion of a string is available. We will go deeper, and the length of that particular link is going to give us the longest common prefix. So, and this is because the character nodes in trie which are present in the longest common prefix must be the single child of its parent. That means there should be no branching in any of these. So, for example, if we having two strings of, one is for example C, S-E-E, and another one is seed, S-E-E-D. So, what will happen? So, S will be there, then E will be there, the next E will be there, and then you will be having the letter D, which is followed by the termination symbol dollar. So, the longest common prefix is, so branching or is actually occurring at the second E in SEE. So, one branch is going to give us the dollar, which is the termination of SEEC, and another branch will give us D and then followed by a termination character, and the longest common prefix here is of 3 characters, which is SEE. So, the characters which are nodes in the trie are present in the longest common prefix. They are actually single child of its parent, which are SEE. No branching should be there in any of the nodes till these 3 characters. So, in this way, longest common prefix we can also find out with the help of trie in a very easy manner, or in a, I can say, in a very efficient manner. And another example which we considered was word matching with the trie. Now, with these two applications of try, we would like to kind of resume back, or we would like to look into the basic operations. So, in the previous lecture we have seen what all kind of basic operations are to be performed on a data structure. So, they are actually insertion, search and deletion. So, the best part of search is actually this search is to be performed when even before the deletion and even before the insertion, because when we talk about deletion, that means we need to look for that particular keyword, or we need to look for that particular word or string, and then we will be kind of deleting it. While insertion, if we we will be looking for the particular place in which at which your the word is to be kind of inserted. So, search is an operation which is going to be performed before the two operations, one is insertion, another one is deletion. So, with this background, let me give you a quick recap of your insertion and search, which we kind of did, which we have performed, or which we understood, which we learned in our previous lecture. So, we have done there the insertion and search, and both the operations are operations can be done by following a particular path from root down to tree, and then kind of insertion can happen. Now, coming to the deletion part, if we have deletion operation in a kitty, now there can be 3 different scenarios of deletion. So, basically 2 different scenarios, one is kind of a successful search, another one is an unsuccessful search. So, unsuccessful search says word is not available. So, if the word is not available, you cannot kind of delete anything. If word is not found, then simply kind of a false indicator is being returned. And if there exists, as in if the word is existing, now there can be 2 possibilities of that word existence. One is it is not a part of any other word, and the second possibility is it is the part of any other word. So, when your word is not found, so first of all I have told you that before deletion a search is to be kind of search is to be performed in order to see whether there is that word, yes or no. So, if word is not there, then we will be simply returning false. Now, if the word exists, then it may exist as a standalone word, or it may exist when word exists as a standalone word, it could be a part of any other word, or it could not be a part of any other word. So, we will be looking into all these examples. So, if the string or if the keyword which you want to delete is a part of any other word. So, for example, here in this situation I want to delete C. So, C is actually out of the 3 characters of C, we have S and E, the 2 characters are part of the other word also, which is set. So, S and E are also required in the keyword set. So, here we can see that branch which is holding this C and set, and if we want to delete C, what will be we will be doing, we will just be deleting this A followed by the termination symbol, and we will not be deleting the part which is common. That means I am talking about S and E. So, S and E will not be deleted, but only the part which is where the branching is occurring, that particular part, that is A and the termination symbol, will be deleted if we actually want to delete C. This kind of consideration is to be taken care if the word which you want to delete is part of any other word also. And after deletion of C, so this will be the situation in your try. If you can see now, S and E are there, what we have deleted is your the branch which was coming out to the node A, and again which was followed by dollar. So, these two nodes we can say we have deleted, and finally we can say successfully we have deleted C without disturbing the word set. So, this provision was made because this C or some characters of this C are actually part of other words also. Now, for example, we have a scenario in which the word is not part of any other word. So, for example, here in this figure, if you can see, if we are going with the word set, if we want to delete the set, this is a very simple scenario, because we need not to take care of any other situation, because this set is not a part of any other word. So, both the scenarios, if your word is a part of any other word, or if your word is not a part of any other word, we can perform the deletion operation. The simpler idea is when the word is not part of any other word, that particular kind of branch starting from root to the leaf will be deleted simply. And if we have kind of another scenario, that will be performed in a different manner. So, here in this figure, if you can see, we have deleted that whole part completely, which was starting from root going to T followed by your termination symbol. And in the previous example, when we were talking about C, the scenario was something of this sort. After the deletion, that the A and the termination symbol are actually kind of we can say deleted. The set part or the common part, which is S and E, are existing kind of as it is. So, here in this lecture, what we have considered is basically we looked into a quick recap of try, and then we drill down into two very important applications of the try data structure. These applications are basically your prefix matching and the word matching. We have looked into the examples of both, and then we have gone through the deletion operation, and both the cases of deletion in which the word is not part of any other word, or the word which you want to delete is actually a part of any other word. We have covered till this point. In our upcoming lecture, we will be looking into more different flavors, different versions of trees, which are tries, which are compressed tries or suffix tries. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.